Good morning, everyone, and welcome to the fourth stop on our cross-Canada exploration in partnership with Edwin. So, as you've been joining us for the several weeks now, you know that we are taking 6 incredible virtual journeys across the country to meet incredible scientists and conservationists who are protecting our wild places and animals. As well, we have our 7th bonus trip coming up on the 19th to our secret location. We'll be live in the field. So we can't wait to reveal that to you and to take your classes on a little virtual field trip. So if you don't know already, my name is Joe Grabowski, and I will be your host for this series. I run an organization called Exploring by the Seat of Your Pants. We bring science, exploration, conservation, and adventure live to classrooms across North America through virtual speakers and field trips. Today's a big day. We'll be releasing a newsletter today with all the updates for our live events coming up throughout the rest of April. So if you aren't already signed up for our newsletter, head over to exploringbytheseat.com. You can find that spot about halfway down the landing page. And then later today, you will get a jam-packed newsletter with events for your classrooms. Okay, so before we get into our speaker today, I want to give a huge shout out to Edwin. They've pulled together some incredible curriculum materials that you can utilize in your classrooms throughout the cross-Canada exploration with your students. They've been sending out amazing updates before the events, the day before the events, an hour before the events. You'll find all the links there for the events and to tune into them afterwards, as well as links to that curriculum material. And I'll share some of those links throughout today's event as well. Okay, let's get to our speaker. We've got Khashiff Miranda joining us. He is going to share some of his experiences exploring above and below the surface of the Canadian Arctic. So he's a PhD student at the Université Laval, whose work focuses on drones, scuba diving, ice, and kelp in the Arctic. Pretty darn cool. One of his favorite ecosystems to explore is the kelp forest of the Arctic. So let's bring him in live right now. Good morning, my friend. How are you doing today?
I'm doing great, Joe. Thanks again for having me on. And what an introduction.
All right. Well, it is awesome to have you joining us. You get to visit an incredible place of the planet. You get to bring super cool technology. You get to jump into those cold waters, meet amazing people. It's a pretty cool career.
I guess I'd say so myself. When you're in the meat of it and you don't really contextualize it like that, you kind of take it a bit for granted. But yeah. No, I'm super spiffed to be getting to do these things.
All right. Well, just a quick reminder to everyone tuning in via YouTube, use that chat sidebar to say hi, but then keep it open for questions, which we'll have after our Kahoot. I will share the link to the Kahoot in the chat when it's ready. So be ready for that. It's going to be a great event. We'll let you take over for a little bit. I'm going to hide myself away. I'll bring up your presentation.
Sweet. Well, welcome everyone. And again, thanks again, Joe, for having me on for this presentation. So today I'll be talking about the wonders of seaweed in the cold world. So I'll begin by talking about a bit of my background, where I come from, and how I've managed to get into the world of scuba diving, and how all of that led me in some way or the other to the Canadian Arctic to be studying seaweed up in the north with drones and diving, as Joe said. So let's go way back to when I was age 9, a little ruffian on the streets of Mumbai. And for those of you who don't know, Mumbai, it is a big city. It's insanely populated. It's one of the most populated cities, most densely populated cities. And we don't really have too much of a close relationship with nature. So when I grew up, I was more of a city slicker. Wasn't too much of a nature boy. But then when I had my first experience scuba diving, all of that changed. So what we did as a family was we did a scuba diving trip out to the Andaman Islands, which are a few hundred kilometers east of mainland India, where the arrow is pointing. And over there, I was hooked. There was something about like the vastness of the ocean, the weightlessness of scuba diving, and just seeing all the drama unroll all around you. And after that, I decided I want to work as a diver. I want to get to spend more time in the ocean with all these animals and weird critters that just infatuated me. So this is what I would do for a living pretty much. So you can see, like, my buddies every single day were fish, snappers, jellyfish, tortoises, turtles, cuttlefish, sharks, you name it, it was there. And I got to spend just an insane amount of time underwater and with other people who were also passionate about it. But one thing that I really enjoyed about this was that I got to go back to the same place almost every week. And in going back to the same places every week, you start realizing certain things about, ooh, maybe this group of fish prefer to stay on this because the temperature is different. Or maybe the moment these kind of jacks that you can see in the top left corner, the moment they come out, a lot of the fish go retreat further into the rocks. And all these tiny observations that we were making and discussing amongst ourselves was, for us, it was a pastime, but I eventually realized that that is what ecology is. It's understanding behaviors, understanding relationships between organisms that live in the ocean, outside the ocean, but it's all about relationships. And that's something that I really enjoyed. I really enjoyed being there and getting to see it and experience it. And I wanted to do that for the conceivable future. So when I went to the University of Chicago, I got the chance to go to Tatoosh Island. Now, Tatoosh Island, it's an island that is in the reservation of the Macaw tribe off the west coast of the USA. Yeah, I was studying in Chicago, but then my professors, Tim Wooten and Kathy Pfister, had the chance to keep going to this island and study it for the last 40 years. Again, going back to the same place to learn things that you otherwise won't see when you just glance at it for the first time. And this island was a special island, especially for the tribe, because this tribe was one of the few tribes that would go out and hunt whales and seals and also harvest a lot of the food that you'd find as the tide goes down. And so it was culturally super significant for them. But ecologically, it was important for us. So again, we're looking at two different species from two different angles. But at the same time, you could ask incredible questions. And we ask these questions in the intertidal zone. So when you scuba dive, it's in the subtidal zone, and the intertidal zone is slightly above. But what is it? So as the moon rotates around the Earth, it moves the waters. So you all may have heard of high tide and low tide, and that is caused by the movement of the moon. So the space between the highest high tide and the lowest low tide, that is called the intertidal zone because it's between the two tides. And this happens every 6 hours. So for 6 hours, water goes all the way down. And as it goes all the way down, it reveals this plethora of organisms and just so many weird and wonderful creatures, all the way from mussels to snails, abalone, sea stars, and seaweed. And this is what we studied. So when the tide would go down, we would follow the tide going down. And unlike scuba diving, where you're restricted by maybe 1 hour, 2 hours per day, you could be here for almost 6 hours running experiments, making observations, and snacking sometimes. And these are the weird, fascinating creatures that we are around. So all the way on the right, you can see these things that kind of look like they're coming out of Aliens versus Predators. And these are barnacles, gooseneck barnacles. And for one of them to grow maybe the size of my finger, it might take 6 to 7 years. Then on the top, we have these organisms called chitons, again, like the size of your thumb. And on the back, on all these striations, they've got eyes. That's where they see. They can notice their predators. They can see where the light is. In the bottom is one of my favorite animals. It's called the nudibranch, which translates like naked sea slug. So it's like a slug, but it doesn't have a shell. And it comes in all these bizarre shapes, sizes, and colors. And all the way on the left, that is a kelp. So that was one of the few kelps that really enjoy just being in the surf, like with waves breaking on it. That is where you're going to find this kelp. And I guess that that begs the question, like, what were we studying over there? So my project was about the competition between seagrass meadows, so these grasses that lived underwater in salty water, and kelp forests, so these giant forests of seaweed, and they'd be competing for space. Like, think about like the African savanna, where you've got the shrubs competing against the acacia trees over there. But in this case, we've got seagrass meadows competing against the kelp forests, and they were fighting for space, for access to rock for them to stick onto, for access to nutrients in the water column. And what they do is very similar to what plants do on land, which is they take in carbon dioxide, they use sunlight, convert that into food that they can use to grow, and in the process, they put out oxygen. So we can test by how much oxygen they're putting out, how much food they're making, and how quickly they're growing. And that is me deep in a tide pool with my oxygen sensor and my intertidal laptop, testing how much oxygen is being generated in this tide pool by seagrasses and kelp. Well, what is a kelp? I've used that word so many times. Kelp is, well, the first thing you can say, it's a home. So in this picture, I'm showing you a picture of bull kelp. Bull kelp, Nereocystis luteceana. And this is something that grows only on the west coast of the USA. And when they start growing, and they grow every year, and they start growing in spring, they are almost microscopic. In the span of 2 months, they can reach the size of 36 meters. And you put that in the context of, I don't know, a building, that's 9 floors. In 2 months, it grows that extent. So in growing that much, it also creates habitat for a lot of the organisms that live out there. And when I say organisms, I mean fish, sea urchins, sea stars, as well as sea otters. So I'm sure all of you have seen pictures of sea otters diving around the kelp forest, or maybe in the Netflix documentary, My Octopus Teacher. So those are kelp forests, and they form a home for seals and sea otters. And like I said before, they take in carbon dioxide and they liberate oxygen. And that makes them the lungs of the ocean. Everyone talks about the Amazon rainforest and how we must save the forest, and we should. But at the same time, the oceans are one of the biggest carbon sinks. And when I say carbon sinks, I mean the oceans is the place where they suck in all the carbon dioxide that we emit through respiration, through breathing, also through the emission of fossil fuels. So in fact, the oceans absorb almost 25% of the carbon that we emit, which makes them really important. And it makes ecosystems like seagrasses and kelp forests and mangrove forests super, super important and vital to the functioning of the world. Additionally, it's food. So baby salmon, they grow up in kelp forest. They like eating it, as do sea urchins. And because at the base of the food pyramid, we like most trees and most plants, they form the food for the rest of the habitat that goes all the way up to killer whales and orcas. So it's crucial as a food source for these animals, but also for humans. The numerous cultures that have developed across the entire world along the shores of kelp forests, a lot of them consume kelp. Think about Japan, the use of wakame in their diet. And if you have most bowls of ramen, you're going to find seaweed in it. And me personally, we work with the Inuit up north, and they also use kelp as an integral part of their food resources. And finally, kelp's also used medicinally. In Japan, post Hiroshima and Nagasaki, that was one of the broths that they would give patients, because there were certain chemicals in kelp that had a way of reducing the amount of radiation inside the body. So as you can see, one ecosystem of kelp can do so many things, and researching these things is something that has been of importance to me. So where do we find this kelp? we're looking around the world, and these blue patches are the places where we find kelp. Now this begs the question, why aren't they around the equator? And it's because kelp like cooler waters. It's too hot around the equator. Where I used to dive in the Andaman Islands, it used to be almost 30 degrees Celsius. So that is too hot for seaweed and kelp, and it's way too hot for corals at this point as well. Okay, so maybe they're not around the equator because it's too hot. But what about when it's too cold in the Arctic or the Antarctic? So I'll let you all in on a little secret. This map was made a while ago. So this was at the time when people thought that it's impossible for kelp to grow up in the Arctic. Why? Because kelp requires sunlight. And in the Arctic or the Antarctic, along the poles, where for 6 months of the year you don't have sunlight, that might be difficult for it to grow. Additionally, it's so cold over there. So how could a species survive? And lastly, there's just so much ice all around. So even if the sun was out, the ice was still covering it. So where would the seaweed and the kelp get access to that sunlight? And that's where we come in. Our current project is looking at the surprising abundance of kelp in these cold polar regions. So for me to study that, I had to say bye-bye to the west coast of the USA, where everything was warm and I could be on the water in a t-shirt, and I had to say hello to the Arctic. Well, this picture wasn't quite the Arctic. This is Quebec. This is Quebec, the St. Lawrence River. But when I say river, it's not fresh water only, because it's an estuary. This is a place where the salty water from the ocean meets the fresh water coming from the Great Lakes. And in this salty region, the entire estuary freezes over. We've all seen lakes freeze over, but seeing the ocean freeze over, mind you, I'm a boy from India. The most ice I'd ever seen in my life was in my fridge. And then I come to a place like this, and like the entire ocean was completely frozen over. I would walk for almost a kilometer and know fully well that below my feet was water. So you swap all this out, but this also gives you an idea of how difficult it would be for something that relies on sunlight to grow. So we can see a beautiful, beautiful sunset happening in front of us. But with ice maybe a meter, 2 meters thick, there's no way for the seaweed that lives underneath to get access to it. And if you compare the pictures of where I used to work on the left, on the west coast of the US, and where I work right now in Quebec, on the east coast, you can see a few differences. One is there's ice. Two is that on the rocks, it's not covered with vegetation like you see in the US. It's pretty barren, and it's because the ice is just abrading a lot of the seaweed out. And that is something that I am studying, is how does ice interact with seaweed and kelp? And all of this, of course, gets even more complicated when you look at what's the future of ice going to be in the Arctic. And from the 1980s all the way to 2023, right now, well, this infographic takes it to 2010, but we can see that the maximum extent of ice that is left at the end of the winter, it's getting smaller and smaller and smaller. And as a result, the entire ecosystems that ice influences is changing. So, like we saw in the previous picture, ice directly impacts these ecosystems, but in an ice-free environment, how might these ecosystems change? To study those, to study how ice influences seaweed in the Arctic and how all of that might change, we go to two places. One is Cambridge Bay in Nunavut, and the second is Angava Bay in Quebec. And we can ask these questions. One, how does seaweed grow? What does seaweed need in these cold places? And two, with climate change, how is all of this going to change? But those are all ecological questions and environmental issues. But for a more fundamental question, how do we stay warm? So in the Andaman Islands, you can see it was 30 degrees Celsius. I was in my swimming costume. I also had a lot more hair that I did back now. Then as I transitioned towards working on the West Coast, we would scuba dive over there as well. But we had our wetsuits. We'd rely on a thin layer of water that would enter the wetsuit and be between our bodies in the wetsuit. And that would keep us warm, this thin layer of water that would not move. And that way we could dive at 15 degrees Celsius. So not too cold, but we still needed a wetsuit and a hood. But when you go up to the Canadian Arctic, it's a different beast. Where I dove, it was 0 to 2 degrees. I've had colleagues diving in places where it was minus 1.9. And that is because there's salt in the seawater, which allows the freezing temperature to go below 0 degrees. But to do that, we use these things called dry suits, where first we stuff all the warm clothes we can onto ourselves, and then we stuff ourselves into a dry suit, which is effectively this giant sack that we can put over ourselves. Does not allow water in like a wetsuit. It's dry. And it also has a valve right here where if you press it, it adds more air from your tank into your suit. And in doing so, it's that layer of air that keeps you warm. We've got our hoods on as well, but keeping warm is of crucial importance for us to do any useful research underwater or over water. So let's go diving. So this is in Cambridge Bay, Nunavut. Our mission over there was to first find out where are the kelp forests of Cambridge Bay, and it was phenomenal. We spent 4 days trying to map out kelp forests with underwater cameras, with drones flying above because the water was really, really clear. And then finally, we found this little patch of seaweed, and these seaweed are called sugar kelp. Why? Because they're sweet when you put them in your mouth. They're sweet. In fact, some of the Inuit up there, they will use this to make their sushi rolls. Sweet, it's crunchy. You can dry them out, and we took these, we rolled them up in little balls, and then we set them at different depths of the ocean to see who were eating them. So this project was Camille's project, and Camille is my buddy in this video, and this is what she's setting: who are eating the seaweed. And then that was in Cambridge Bay, which is in the central Canadian Arctic. And then I'll take you all now to the eastern Canadian Arctic, which is Ungava Bay. So over here, the tides are the greatest in the world. It goes all the way to 15 meters. That's around four floors of a building, up and down. And as you can see in this drone shot, all these patches of black, that is all seaweed. That is all seaweed growing on hard rock. And it's immense. It's immense. And as the tide goes out for 15 meters, it could expose almost 2 to 3 kilometers of land. Now, this is a special project because it's in collaboration with the local communities up there. So there are around 14 tribes, communities that live up in Ungava Bay. And all of these tribes have different relationships with marine resources. The communities that we work with primarily focus on seaweed, mussels, whales, seals. So this camp was a camp made for kids between 9 years old to 16 years old. And the goal was to have elders kind of come in, like a summer camp, and show these kids, how do you hunt for all these different animals? And how do you use different parts of the animals to make different products? Like, how do you take the skin off a seal to make rope? Or how do you go and collect seaweed? And that's where I would come in, because you had all these elders talking about hundreds and hundreds of years of knowledge of how do you interact with the natural environment. And then I could come in and add the scientific outlook of like, all right, we can test a lot of these things as well, and we can understand how in future scenarios where the environment changes in an unexpected fashion, how will the world respond to it? And that brings me to my final slide. It's that the future of the environment of marine research, it's cross-cultural. And this is a picture of me after I had logged up bags and bags of seaweed that we were weighing, and we were identifying how much is there, because that's a crucial question. No one really knows in Ungava Bay how much seaweed is there. This important sink of carbon dioxide. How much is up there in Ungava Bay? And when we went there, it was surprising. And then we go up there and we're talking to them, and we bring up lots of seaweed, and we sit down and we just talk. And I could talk to them about the importance of seaweed in the rest of the world, the parts of the world that they would not have access to. Whereas they could tell me how important seaweed was for hundreds of years of their culture. What times of the year are best to have seaweed? Sometimes where do you find it? Sometimes where do you not find it? And it's this bridge between cultures that really makes science more fun, more interesting, more useful. And that is where the future of science is going, because we're increasingly working in further and more remote places. And for one, we need people to help us understand how do we navigate these places in a safe fashion. And the best people to do that, of course, are the Inuit. And two, it's that modern science has been lacking a lot of this indigenous knowledge, which we're finding increasingly useful in combating global warming, climate change, because it's honestly these communities who are the best stewards of their environment. And that's kind of where I want to leave you. Like the future of the environment, it's not one or the other. It's a mix of working both with communities as well as with scientific methods. And I like to take also this moment to kind of reflect a bit on like that first picture I showed you of that little boy in Mumbai, and found his way up into the Arctic regions of Canada, working with communities. And I've really been fortunate with the opportunities that I've got, the people that I've met, the connections that have been made. But also I think it goes to show that if you can dream, if you can be creative, if you can follow through on a lot of your ideas, you can make some ridiculous things like putting an Indian person up in the Arctic researching seaweed underwater. You can make that happen. And with that, I'll end. And thanks to all the sponsors who've helped me out. And thanks to Joe for having me on.
All right, Khashiff, thank you so much for an amazing presentation. Your path to the Canadian Arctic was a winding one, but I think you've ended up in the right place and really kind of a hub of where our planet is changing faster than almost anywhere else.
Right. Absolutely.
Okay, well, we're going to play a little Kahoot now. So 2 things to remind groups. If you're going to join the Kahoot, here is the information. I'm going to pull it up on my screen as well, share my screen. So kahoot.it, and then your PIN number's there, 117-5165. And then use that chat sidebar. Let's get some questions coming in. I see a couple have come in already. So let's start getting some questions into that chat sidebar. I'm going to share my screen, and let's start getting this Kahoot ready to go here. I see some students in classrooms starting to join already, which is perfect. So as groups join us, let's get started with some questions. So I have some questions that have already come in via the chat, and I love this one here. This is a great one from Naheem. The question is, on land, we know that birds and mammals can disperse seeds of plants. Does the same thing happen in the ocean? Can seaweed and kelp be dispersed that way?
My gosh, that's a brilliant question. And that is like the $1 million question. It's like, how are seaweeds getting to the places they're getting? So on land, yeah, you have mammals and birds helping out, but also some seeds use the wind. And in a similar way, the ocean currents are the wind of a lot of these animals. And it's a much more effective way of dispersing. But there have been some experiments done where they found that tiny little crustaceans, like little crabs, can have the spores of kelp, taking them all around the world effectively. So It's a complex question. Scientists haven't completely understood it, but I don't know. Maybe that could be your PhD when you get up here.
All right, very cool. Well, I still see students joining at a fast rate, so I'm going to leave it for another moment here. We'll do another question here. So your dry suit is very different than your wetsuit in that the idea is it keeps the water out. But have you ever been on dives and had a leak in your dry suit?
That is the worst feeling ever, because the rest of your body is warm, and then you have a single spot of your body that is ice cold. And I remember my first dive I did in in a dry suit. I I was so excited to be underwater that when you're cold, you should end your dive. I did not. I was just happy to be there. I come out just absolutely freezing, and I was like, I, is a dry suit supposed to be like this?" And they were like, "No, you're supposed to be comfortable and warm." So yeah, it's not fun, but you got to keep good maintenance of your equipment.
All right. Well, I think we are ready for some Kahoot action. There's still a few stragglers coming in, but we should get going so we can really get into the Q&A proper. So we're going to have a 3-second count in, and then we'll be off. A couple of the questions are 20 seconds to get your answer in. Remember, the quicker you get that right answer in, the more points you're going to get. And then a couple are 30 seconds because they're a bit longer question where you have to read a little bit. But I will read the question out to you as well. So let's get things going. All right, our first one is a true and false. Ecology is all about understanding relationships. Is that true or is that false? Ecology is all about understanding relationships, understanding those relationships in our ecosystem between plants and animals, us, all those different parts. All right, good job, crew. That is absolutely true. Let's see what that does on our leaderboard. We got the hero owl holding on to that top spot. Let's go to our next question. This is going to be a multiple choice. So you've got 30 seconds for this one. The intertidal zone, is it the highest tide? Is it the lowest tide? Is it the area between the highest and lowest tide? Or is it the area that's always underwater? So you have 4 options there for the intertidal zone. The highest tide, the lowest tide, the area between the highest and the lowest tide, or is it the area that's always underwater? All right, we had a bit of a mix in our answers there, but C is correct, that area between the highest and the lowest tides. And I don't know about you, Khashiff, but I love getting out at the low tide and exploring the tide pools and all of the plant and animal life on those rocks in between.
Really, check your local tides and make your way down at one like low tide. There's so much to find out, even in Mumbai.
All right. The social squid has snagged that top spot. Let's go to our next question. Oh, this is a multi-select, so you need to pick 2, 3, or 4 answers here. Click everything kelp does in the ecosystem. Does it provide food? Does it provide homes? Does it provide medicine? And does it provide oxygen, so lungs of the planet? So every single one of those things that kelp does for the ecosystem, for us, other animals, click every one that you think applies. So we know it's not going to be 1 because it's multi-select. Are you going to click 2, 3, or all 4 of those options? Okay. Good job, crew. Technically, if you click 1 or 2 or 3, you're right, but all 4 of those things are things that kelp does, ways kelp can be used, ways that kelp provides things in the ecosystem like food and homes. And I can see from our answers that over 150 students clicked all 4 things. That's great. The space kitten is taking that top spot. We have one more question before we get to some more Q&A. Ecosystems, they aren't changing the Arctic as we're losing sea ice. Is that true or is that false? That ecosystems in the Arctic aren't changing as we're losing our sea ice. True or false? They aren't changing at all with the loss of sea ice. All right. Awesome work. That is absolutely false. The sea ice is an incredibly important part of the Arctic ecosystem. And as we lose it, it is going to change those ecosystems. And some plants and animals will be able to adapt. Some will move. Others just won't have that opportunity. So our podium, third place, we've got the eager bunny. In second place, we've got the cute elk. And holding that coveted top spot today is the space kitten, held on for the last 2 questions. All right. Good job, gang. Let's switch over now. Get those questions into the chat. We also have a live camera classroom joining us, so I'm going to take their questions directly. In fact, let's start with them first. So we've got our primary ELL crew hanging out with us today. How are we doing today? Okay. There we go. We can see it now. Let me take this banner away so we can see even better. There we go. All right, Miss Dorto's crew.
Okay. Rudy, Maria. Okay, there we are. What is your question?
My question is, what are the most mysterious creatures you have found in the sea?
Mysterious creatures.
Like the most dangerous.
Oh, weirdly, it's this fish called a stonefish. So it looks like a stone, but it's one of the most poisonous fish you can ever see. And that's how it catches its prey. It looks like it's any other stone, and then the moment it doesn't expect, either stings it or jumps at it.
Wow.
And it's hard to find, but I'd say that's the most dangerous one I've seen. Of course,
did you ever touch it?
No. I like living.
Did somebody else touch it?
Yep, one of my friends. She was this Italian dive master, and she touched it, and she instantly had to get evacuated all the way back to India, the mainland India, and then have her entire blood flushed out. And she lived. But that was, I know. No, me too. But that was.
When that happens, you're in your mind, you're uh-oh, but then you're phew, it happened.
Yeah. 1 month later, I was, phew, it happened.
Yeah. All right. That's a really great question. Get another one ready, because we're going to come back to your class after I take a couple YouTube ones. So have another one there and ready for us. Thank you for that question. As diver, that's one of the reasons they tell you is be careful. Well, you shouldn't really put your hands on the reef or the coral or the rocks at all. But that's one really important reason to definitely keep your hands off of, because you might not notice what you're putting your hand on, even if you're steadying yourself.
There you go.
All right. I've got lots of questions coming here in the comments, so let's get into some of them. So we've got a 4th grade student. Well, this is an interesting question. I think you'll be able to put some context to this. Wondering, do you have a favorite type of kelp or seaweed? Is there really a difference between the two?
Yeah, I'll take the second one, which is that difference. So seaweed, it's kind of this umbrella term for a lot of the things that aren't plants. It's like this big argument of what is a seaweed, what is a kelp. But when we use the word kelp, we usually talk about the big brown seaweeds that are growing in the ocean. But when we think about seaweeds as well, we can talk about the tiny green ones that you find, that you dry up and you can use as rolling for your sushi. That's also a seaweed, but that would not be a kelp. But in terms of my favorite kelp, there's this one kelp called winged kelp, and it has these little wings at the bottom of it, which are actually where the babies live, the spores. And that is the kelp that the Inuit eat up there, and it is delicious. So you're in the intertidal zone for 6 hours, you're hungry, food's right there.
Very cool. Another question here. This is from some 4th graders, and they're wondering about eating kelp. The nutrients, is there lots of nutrients? What are some of those nutrients in kelp that make it so maybe sought after?
So you have these. So it's rich in iodine, which is responsible for like the taste that you get from it. It's obviously very salty, but also when we think about the things that maybe your parents take as supplements, like omega 3s, everyone talks about, oh, you got to have fish for that. But where did the fish get it from? A lot of that is coming from kelp. So there are these macronutrients that are just really important for us that we derive from kelp. Yeah.
Okay. So let's, I've got a few more here coming in the chat, but before that, I can see someone in our primary crew waiting for their question. So let's go.
Yes. Okay, ready?
And hi, how you survive there in the sea?
How do I survive?
Yes.
Well, it that's a big question, but I think I'd have to take my hat off to the Inuit boat captains who kind of take us all around, because it's dangerous, but the people out there, they really understand the water. The local communities, they understand the water and they understand what is safe. So we're very safe. We don't really try to be cowboys and take on the sharks of the ocean. No, 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 no. We're trying to be very level-headed about the work we're doing, but also we rely a lot on the indigenous knowledge of the communities up in the north to help us be like, maybe don't dive over here, or maybe go over here, this might be more interesting. So that's a big component of our safety.
Right.
Thank you.
Great question.
Great question.
And I think you'd agree with me. Maybe you feel the same way. I've been diving since 2007 in all kinds of situations, but every dive you plan it out. It doesn't matter how long you've been diving for, how familiar you are. You got your dive buddy, you check your gear, and I always feel those little butterflies, right? You're excited, you're a little bit, maybe a tiny bit nervous, you've planned it. Once you hit the water, everything just goes out the window. Like, you're just so excited and you're so immersed, but there is a lot of planning and a lot of, to make sure that everybody comes back okay.
Right. And like, it's that planning that kind of gets ingrained in you, so that when you're on your dive and everything goes towards your intuition and your instinct, you kind of have that planning inside you to execute what you had decided to do.
All right. So, Wolf Kid would like to know, are there any species that you have found really unpredictable while diving?
I think so, yeah. That video that I had shown y'all about Camille and me diving underwater, we didn't expect to see seaweeds over there at all, because what we know about seaweeds, at least what we know about seaweeds from the south, from the warmer waters, is that one, seaweed loves hard rock to stick onto, and two, they love being in just a lot of wave swept energy. But the place where we found that patch of seaweed, it was only sand, and that's something like we don't usually see ever. And so that's always a surprise when you go up to the north. The rules are different. The rules are completely different because of the way the sunlight works, and the way the temperature regime is, and the amount of sea ice, like I talked about. And because these rules are different, seaweeds are always surprising up north.
Yeah. I think that's, something students should really take in mind as they join these events. Keep in mind is that you might hear people say there's nothing left to explore, discover, or we figured everything out, but that couldn't be further from the truth.
Exactly. Yep.
All right. Clara in 7th grade would like to know, you mentioned that there was salty kind of tasting seaweed. You mentioned that one species that has a sweet taste. What gives it that kind of a sweet taste as opposed to maybe salty?
That's a great question. I don't quite have the answer for it, but if you think about all the plants that you live in, I mean that you've seen, you've got basil, you've got spinach, and all of them have different properties which kind of tie into where they grow, what soil they're exposed to, what part of the ecosystem that they influence. And you have all these tiny things that have kind of shaped the way that specific species has evolved to developing those characteristics. So a lot of factors, But off the top of my head, you've stumped me, and that's a great question. And I'll think about it and try to get back to you about that.
All right. Well, it's always great to see students thinking as well. And we always assign a little bit of homework when this happens. It's a great opportunity to do a little research, to practice kind of your skills as a scientist. Maybe come up with a hypothesis why you think, and then get online and see if you can find that answer as well. Clara, 7th grade. Oh, no, that's the question I just did. We don't need that one again. Okay, Anthony this time. Anthony would like to know, do you think we're going to lose sea ice in the Arctic? And, we don't know exactly, but is there a rough kind of time frame when that could happen?
I think currently the big fear is losing annual sea ice in the Arctic. And I want to draw the distinction because annual sea ice is sea ice that is there in the winters and there in the summers. So even during the hottest period of the year, you don't lose that. And that is the big fear of us having an ice-free summer. So there is I'm not too sure about the dates. I want to say 2050, but I'd recommend, like Joe said, maybe a quick Google can solve that. But yeah, so there is that future looking at us. Yeah, we lose the summer sea ice, but in the winters, sea ice will be there inevitably, but in a different form.
Okay. So one more question here before we wrap up. Seaweed and kelp, we know it's eaten when it's alive, but are there scavengers and other things that might consume it when it dies?
Yeah, I do wonder if you've thought about that question from personally walking along the beach. But if you ever look at seaweed washed up on the beach, and you by mistake or maybe on purpose lift up a little bit, you'll just see these tiny bugs feeding off it, or you see like little holes all around it, and those are created by, depends on the place where you are, but isopods, and these tiny marine bugs that kind of amphibious. They can live on land, they can live in the water, but once they come on land, something needs to be done with them. Like in a forest where you have fungi and other bugs taking all the dead plant material and reconverting it to something useful. The same thing happens along the beaches where you have a lot of bacteria living on these seaweeds, as well as these bugs that are crucial towards linking both like I said, ecology's relationships. And these bugs would be the way of linking seaweed coming from the oceans to a lot of the nutrients that are now available on land through the movement of these bugs. So yeah, great question.
Okay. So as we wrap up today and we think about our changing planet, and this might be a question that still remains to be answered, but do you think that we'll see maybe the range of kelps and other seaweeds maybe expand a little bit in the Arctic? Or is that still to be determined?
Oh, absolutely. Inevitably, kelp will expand towards the poles. And the main reason is that it does not like the heat. So as the polar regions become warmer and warmer, have more access to sunlight, a lot of the species that I used to study in the USA are likely to go up towards the Alaskan Arctic. And it's the question now is, how do these warmer species of kelp interact with a lot of these Arctic species of kelp, which are two different kinds of species, all specialized in different things. Now, how will those two communities of kelp interact at that frontier? And that's the big question.
All right. Well, I want to start with a huge shout out to our classrooms for joining us today. A shout out to all the classrooms who will be joining us later today and throughout the week. I will send the link to the Kahoot to everybody and the YouTube link so that you can use it this week. Reminder, a big shout out to Edwin. Here's your teacher travel kit. Here's a link right there. Take a screenshot if you don't have it. I'll include it in the email as well. And then coming up, we have our next stop number 5. We'll meet Cody out in the Maritimes, and we will learn about the endangered North Atlantic right whales and how we are studying them. That is on April 14th at 9:15 a.m. Eastern, so not too far away. Khashiff, thank you so much. That was an incredible journey today. Fun
Thank you,
Kahoots,
Joe.
amazing questions. Always a pleasure to have you join us, whether it's in English or in French. It's great to have you with us.
Yeah, appreciate it, Joe. Thanks for having me out. And thanks to all the students, the great questions. And I can already see some potential new people in our lab.
Excellent. All right. Well, we'll see everybody on the 14th. But for now, we are going to sign off. Thanks so much, everyone. Have a great rest of the week.